In this video, I'll provide an introduction to the fundamentals of Arduino. No prior experience is needed to understand these principles presented. Fundamentals of Arduino wiring and programming will be introduced by creating a simple circuit that changes the color of an LED light when a button is pressed. After completion of these instructions, you should be able to apply the simple principles introduced into more complex projects. You will need an Arduino Uno, a male USB to male USB Type B wire, also known as a printer wire, a solderless breadboard, a tricolor or RGB LED, a tactile push button, jumper wires, a 220 ohm or higher resistor, and a 1 kilo ohm resistor. There are many different connectors on the Arduino board. These black connectors that stick up are referred to as pins. There are several groupings of pins on the Arduino board. The pin name is located on the board next to the pin. Here we have the ground and power pins. The power pins are 5 volt and 3.3 volt. Down here are the analog pins. These read voltage values and output a value between 0 and 1023. These are communication pins and digital pins. Digital pins only output values of 1 or 0, also referred to as on or off and high and low. The digital pins can be set to either input or output. When used as an input, they will look for a voltage above a threshold and will output a value as high. The breadboard is used to make electrical contact between components without having to solder them. Beneath the pins on the breadboard, there are rails that will contact the components when they are inserted and conduct electricity. On the sides here, there are 2 rails that run vertically. Anything placed in this rail will be electrically connected. In the center of the board, the rails run horizontal up to the center groove. Rows are not connected across the center groove. When inserting components, they will be placed so that each pin on the component is on a different row, so they are touching different rails. First, power must be supplied to the breadboard. This is done by attaching a wire from the ground pin on the Arduino to the blue vertical rail on the breadboard, and by attaching a wire from the 3.3 volt pin on the Arduino to the vertical red rail. The LED has 4 pins. The longest pin is the ground pin, and each of the 3 remaining pins corresponds to a color on the LED. Giving one of those pins a voltage will illuminate the LED that corresponding color. Insert the LED into the breadboard so that each of the pins is in a different row. Take note of where the longest pin is. A resistor is needed to reduce the current across the LED to prevent it from burning out. It was determined a resistor of at least 220 ohms must be used. A higher resistance can be used, but it will reduce the brightness of the LED. Connect the 220 ohm or greater resistor from the longest LED pin to the blue or ground rail on the breadboard. The direction of the resistor doesn't matter. Next, attach wires to the remaining 3 LED pins and connect them to the digital pins 9, 10, and 11 on the Arduino. For this project, the order the LED pins are attached to the digital pins doesn't matter. The LED is now completely wired, and it is time to move on to the push button. The push button has 4 pins which are open circuits or not electrically connected. When the push button is pressed, the circuit will close and a connection will be made between all 4 pins. Place the push button across the center groove so 2 pins are on each side. We will only be using the pins on the same side that the LED is on. On one of those pins, attach a 1 kilo ohm resistor and connect it to the ground rail. This resistor pulls down the current. On that same push button pin, attach a wire and connect it to digital pin 12 on the Arduino. This will send a signal to the Arduino when the push button is pressed. On the other push button pin, attach a wire and connect it to the 3.3 volt rail. The wiring is now complete and it is time to program the Arduino. The Arduino IDE, or Integrated Development Environment, is needed to program the Arduino. This can be downloaded from the Arduino website, arduino.cc. Click on Software and Downloads. Click on the download link for your operating system and install the IDE. After the download is complete, open the Arduino IDE and you should see this screen. This is the programming environment for Arduino. The IDE uses the C programming language. I will walk you through some of the tools in the IDE. Under the File drop-down, there are the standard tools such as Save and Open. Some example scripts can be found here too. Under the Edit option, you have the standard Undo. Towards the bottom is the Comment and Uncomment tools. Those options can be used to switch the highlighted code to a comment which isn't executable and is only there for reference. Under Sketch, there is the option to verify the code, which checks that there are no errors in the code. There is also the option to upload the code to the Arduino. Under Tools, you can view the serial monitor, which shows the serial communication received from the Arduino. Under Tools, you can also select the board and port options, which are important for communicating with the Arduino. Help has some additional resources for Arduino programming. There are some additional options below the drop-down menus. This button verifies the code, this one uploads the code, and this displays the serial monitor. Arduino code has two main functions. The function names are setup and loop. Executable code for the functions are placed in between the two brackets. The setup function is executed once when the Arduino is turned on, and the loop function runs continuously while the Arduino is powered on after the setup function. We will begin in the setup function. The gray line is a comment which isn't executed by the Arduino. It's just there for the programmer's reference. Comments can be added by typing 2 forward slashes before the comment. I'm going to reorganize this function because I prefer to have the brackets lined up in the same column. We will begin by programming the setup function. First, we need to set the modes of the digital pins. This can be done using the pin mode function. The inputs for the function are placed inside the parentheses and separated by commas. For the pin mode function, the inputs are pin number and the mode, which are either input or output. The mode is typed in all caps. We will start by declaring pin 9 as output. Every line of code must end with a semicolon. This signals that a statement is complete. Pins 10 and 11 can be set to output the same way. These are the pins that connect to the LED color pins. Next, we need to set the push button pin to input. This is done using the pin mode command as well, except this time the mode is set to input. Now we need to set an initial state for the LED. This will be done by turning the digital pins to either on or off. To turn a digital pin on, the digital write function is used. The inputs are the pin and mode, where the mode is high or low in all caps, which corresponds to on and off. We will start by setting pin 9 to high. We only want one pin on at a time, so we will set pins 10 and 11 to low using the digital write command as well. Next, we will declare a variable that keeps track of which pin is on. This is done above the setup function. Variables are declared by declaring the type, then the name, and a value. We will declare the variable as an integer, which is abbreviated int. We will name it pin_on, and we are starting with pin 9 on, so we will set it equal to 9. Next, we will move on to the loop function. We need to determine if the push button is pressed by using an if statement. If statements take an equation as an input and only executes the function if the input is true. To determine if the push button is pressed, we will read pin 12 using the digital read function and see if it is equal to high, meaning the button is pressed. When checking logic, 2 equal signs are used because 1 equal sign is used to declare variables. Now inside this if function, we need to check which pin is currently on. This can also be done using if statements. First, we will check if pin 9 is on using an if statement. The input will be pin on equals 9 using the 2 equal signs. Inside the function, we need to update the LED status. We want to turn pin 9 off and 10 on. We will use digital write to turn pin 9 off. Now we will use digital write again to turn pin 10 on. We will use digital write one more time to make sure pin 11 is off. Now the pin on variable needs to be updated and set equal to 10 because pin 10 is now on. We need to use the same logic now to check for pin 10 and 11 being on and update the LED. This time we will use else if instead of if. Else if just means if the first if is false, check this if statement. We will use the same functions as before, except if pin 10 is on, we will turn 9 and 10 off and 11 on and set pin on equal to 11. If pin 11 is on, we will turn pin 9 on and turn pin 10 and 11 off and set pin on equal to 9. The code will run several thousand times a second. It will run quicker than we can press the button, so we need to stop the code for a short duration so it doesn't update rapidly while the button is pressed. This is done using the delay function. Delay takes an input of time in milliseconds. It will be placed in the bottom of the if digital read is equal to 12 function. 250 milliseconds is a long enough delay. The code is now complete and it is time to upload. Plug in the Arduino using the USB cable. The board type and port need to be selected to properly communicate with the Arduino. Click on Tools, Board, then Arduino, Genuino Uno. Now click on Tool and Port. There should only be one option listed that says a port name, then Arduino Uno. Click on this. You can verify that you're correctly connected because the board and port name will appear at the bottom right. Now click on the arrow in the top left or the upload button. The first time you run the code, it'll ask you to save. Name it whatever you want. Now the code will attempt to upload. This may take a minute. If it uploads correctly, you will get this upload complete status here. You may also have an error that prevents your code from uploading. I'll show an example. If you get this, it means there's an error in your code. It will tell you what the error was and highlight the line it was on. Now that the code is uploaded, it's time to test. The LED should illuminate as soon as the code finishes uploading. When you press the button, it should toggle to the next color. Press it again and it will go to the third color. Press it one more time and it will return to the original color. If you hold the button down, it'll continuously change color. This concludes my introduction to Arduino.